Okay, in this lesson we're actually not going to look at any examples. It's going to be a very quick lesson, but it's kind of a summary of everything we've done in this entire unit in words, which kind of simplifies things, unfortunately. What we've done in the previous two examples is set up an entire optimization problem. So how do we set up constraints to find a possible solution region, and then investigate the corners in our objective function to find out what the maximum or minimum possible combination is. We've done word problems with narrow and wide boards for a particular construction company. We've also done just some mathematical problems where you're just given the signs to set up a solution region and investigate the objective function here. So you may want to look at the two previous lessons for that. Now if I'm to summarize or simplify kind of what that is in words, here it is. To determine the optimal solution to an optimization problem, if you'd like to set this system up in its entirety, here's what you would do. You would first of all determine the variables. So is this narrow boards, wide boards, spiders, crickets, what are your variables? And label the axes. Next, what you'd want to do is write a system of inequalities. To represent the constraints. If it's not a word problem, those will be given to you. If it's a word problem, what are the inequalities? Do you need exactly more than double the amount of hot dogs than hamburgers, or no more than 100 hot dogs, or less than 40 narrow boards? Whatever the constraints happen to be, you set up that system of inequalities. Thirdly, what you're going to do is graph the solution region for the system. So once you have the system of constraints, you're going to graph the solution region, and then we have to investigate the corners, and that's what step 4 and 5 are about. First of all, we must identify what must be optimized and write an objective function. In some cases, the objective function will be given to you. In other cases, you have to come up with it on your own. Like for example, we had to come up with our own objective function for maximum and minimum costs for this problem here. The objective function was the cost of narrow and wide boards, or in the problem before that, the objective function given to us. Okay, so step 4 may not be necessary depending on what type of problem you're doing. Step 5, finally, is evaluate the objective function by substituting the values of the coordinates of each corner. And that should be into the objective function. And then we just state our maximum or minimum solution, also called our optimal solution. And that is a simplified version of how to do these problems. In the next lesson, what you'll see is we're going to do your first homework problem together.